All right. I don't know if Jordan will be in or not yet. I'll keep my eyes open for him too. I accidentally
Okay.
called Callie by mistake, so that
Oh,
was my bad.
no. Just make sure you hit the
Um,
record button.
oh yeah, I already did. You bet it was like the first thing I did as soon as I get here. It's like I'm not gonna let that happen again. I still can't believe that it makes you have to do it twice. And like I feel like once you hit it, it should just go. But I get like also that we took a break in the middle of all that as well. So, oh
Yeah,
goodness.
they may not wanna do a they may not I don't know. I don't know what I'm trying to say. I'm just yeah,
Maybe it's like an invasion of privacy sort of thing. Because
probably.
anytime you record, it's like make sure you let everybody in the party know that you're recording. All right.
It
Well,
sometimes does that already, because
mhm.
it'll pop up that little notification that's like, "Hey, you're being recorded."
Yeah, my parents' Ring doorbell does that for goodness sakes. It's like anytime somebody walks past or a car drives by, it says that out loud.
Hmm.
All right. Well, um, we'll just go ahead and get started. Let me close out what I got. And come on. Let me get back to a clean slate. I always like kind of going through the motions of making sure everything is cleaned up so I'm not dealing with the hot mess of a bunch of different packets a bunch of different screens pulled up. Um,
Oh, looky
what was
there.
that?
It's a picture of stairs.
Yeah, that was just conveniently like there. I didn't even mean for that to happen. All right. Well, I got some cool stuff that Greg was able to fish out of the stair vendor or the metal vendor for the staircase. So we'll be looking at that here in just a moment here as well. If you want, because you are training, I would just go into indirect and say that you're training on stairs for today. I'm going to actually sign into the staircase since it's got my name on it here. If it's in T sheets, I'll clock into it. It's 45719. Boom. Okay.
Already done.
All right. Oh, we're on a stairs now. That's actually that thing you guys drew the other day, the faceted panel thing. You can't really tell because the picture's really zoomed in, but that's what that is.
Hmm.
All right. Bradley
Looks like a
Law.
drawer.
Yeah, those things actually did have drawers on one side of them, which is kind of cool. All right. Well, um, all right. Well, okay. So this staircase, it is on level 19 of Bradley Law. Bradley Law is project 6358 if you did want to sync it for anything. Um, we're going to take a look
You
at
said
the
six
architecture
three five
roles.
eight.
Mm-hmm. Yeah, I am
Might
going
already be
to.
synced.
Oh, yeah, you may already have it because you might have done some. Actually, you probably do have this one synced because I think you did some
Yeah.
changes to it.
Six three
Um,
five eight. Bradley Law.
where? Oh, 19th floor. Oh, that's right. Because you guys just did all the cabinets for that one. That's right. That was just earlier this week, believe it or not. Okay. So there's one thing that's a little bit wishy-washy at this point. There's a um, planter. They call it a plinth planter. It's got multiple names. Underneath of the staircase, there is something there that that is kind of undefined at this point. Um,
Hmm.
typically, what that is, and we'll see it when we get to the rendering from the metal vendor, but typically, what that is for ADA purposes, they actually do need something under the staircase. And the reason for it is for people that have seeing disabilities, when they have a walking stick or whatever those things are called. Um, if you were, if you had a seeing disability, you had a walking stick, and you were walking around a building, your walking stick's not going to tell you there's a staircase there above your head. So what they have to do these days is they have to either put a cane guard or some piece of furniture below their staircases, typically like this. So that way, if somebody with a seeing disability was to walk through the building, there's no chance that they're going to run their head right to the side of the stairs, because we don't want that. So
Yeah.
these days, you see a lot of that on staircases. There's usually either a planter or some kind of a bench or something underneath of it. And that's just kind of a necessary thing these days, which is kind of cool. It makes the stairs look even neater anyway if they have something like that. But it's also serves a really good purpose, though, too, to make sure that people don't get injured while walking through this building. So the architect actually didn't really draw much of anything for that staircase, but fortunately, we do have, and this is something that typically we're going to do every time we draw a staircase, is we will request the steel vendors, like either their CAD drawings or their metal shop drawings for their construction of their stairs. Because when we do staircases, we very seldom actually do anything that we have to make structurally sound, like on our end. We usually are cladding some kind of a metal structure. So I would say almost, well, practically 100% of the time, there's one staircase we've done in the history of on-site that I'm aware of that wasn't like that, and we're still fighting it. It's a big deal.
Dang.
You got to get it stamped by a structural engineer, which we kind of talked about that the other day. It costs a lot of money to have somebody do that. Plus, it's a real pain. It has to be inspected. It has to, it has to meet a bunch of code. So a lot of times when you see a staircase on a job, really what we're doing is we're essentially decorating the steel, if you want to call it that. We're cladding over what the steel vendor has provided. And that is the case in this staircase as well. So looking at this, and actually, we had that book, that page we were looking at the other day. I'm going to take a picture of, let's see, that was in the 800 section, I believe. That page that had the graphic that kind of showed you the different terminology things that go into a staircase, like what things are called, because there is a whole language of stairs. It's not that hard to learn, but I'm going to take a picture of this, or maybe I'll scan it in real quick if it lets me do it real quick. And I'll email it to myself, send it to the group chat so you guys have something to look at. Now, I've never scanned a book before. This is going to be interesting. I feel like I'm at the library. Scan and send.
But it's your own book.
I know I'm messing up the binding on it because I have it laid flat on the copy machine. Oops.
Uh-oh.
Oh, it's all good. I had to make a change in my settings, I guess. Select original size. I guess we're going to go 11 by 17. Let's see this thing. Oh, it worked. Okay, cool. It scanned the whole thing. Awesome. Okay. Cool. All right. So I'm going to bring that up in this meeting here. Start sending. Yes, please. Okay. That way you guys can see this. We will go over the basics of stairs first before we get into drawing it. But just going over some stuff here. Like I talked about, we usually will request the metal vendors either their CAD drawing or their PDF drawing to make sure that we're lining everything up that we have that we're building around what they're building. Because a lot like a lot of other things you see in the world of architecture, like if you see, I'm sure you guys have, you see like a cabinet, a bench, a bar. I mean, there's a lot of times where you see something on an architectural and it's not even really drawn close to what we would build it like. So a lot of times what we'll do is we'll take what we can get from the metal vendor, because a lot of times the metal vendor will redraw what the architect has drawn to meet their standards. So rather than trying to build off of what the architectural shows, we try to usually build off of what the metal vendor has provided, because it's going to be more accurate to what's actually being built in the field. All right, let me see if I can crop this down. There's a way to do it. Oh, I got a better idea. I can make this work. I can make this work. That other AWI book is going to be showing up here in the next, well, I think it gets delivered today. Pretty excited for that too.
Yeah.
Okay. There we go. That's better. Let's make this bigger and then we'll mark it up. Okay. Their terminology 101. All right. So, all right. Here we go. All right. So the type of stairs that we're used to seeing, we do get a lot of the same types of verbiage. Like the side of your staircase, you usually will have what's called a stringer. A stringer is just a sort of diagonal member that actually goes along the side of the steps. Sometimes you might have one that's in the dead center too. So if you do, it's no big deal, but that would also be considered a stringer too. It would just be like a center stringer. So we usually don't deal with a lot of newel posts like this, but I have seen that on some drawings before. Had a staircase recently for a job called Print Temps that actually did have a couple of newel posts, but they were just a big cylinder. They weren't like anything fancy like this. These are sometimes referred to as balusters, which would be like any vertical pieces that support the railing. We do sometimes see stuff like that. And in fact, the staircase that we have does have something similar to it, but it's made out of metal. And the handrail is also something that we're going to be talking about too. But the handrail on this staircase is by the metal vendor as well. So it's something that really isn't going to play a big part in our drawing. But let's see, let's call this a newel post. There we go. Let's see. I erase that too. Let's call that a stringer. Okay. Minor riser and stringer. Yeah, we don't usually do that type of stuff. This is kind of more of like a residential staircase when we're looking at it, but a lot of the terminology does actually pertain to most staircases though too. So a couple other things here too. The piece of the stair, well, okay, so let's start here. So vertical pieces of the steps will always be called risers. Horizontal pieces of your steps are always going to be called treads. So we got treads and risers, risers vertical, treads horizontal. And then at the front of your tread, there's something that's called the nosing. Let me erase this and cove part because really we don't really refer to it as that. But you have your nosing at the front, which is the little piece that overhangs, which we'll get into that because you can kind of see it over here a little bit. Typically, that's about an inch of overhang on most staircases, and we'll be seeing something like that on the staircase we're building today too, I believe. So we're going to look at that here in just a moment. Yeah, so terminology that's important for stairs. I guess you want to come into here. Let me erase some more of this stuff because this stuff doesn't really matter to us. This is more, again, more residential than anything, and I don't want it to get too confusing. So I'll clean this up a little bit. I feel like I'm committing a fraud here by doctoring up a graphic from a textbook.
No, it's only if you publish it that it's fraud.
I'll publish it. Now, I think I'm not publishing anything here. I'm not rewriting the AWI book. I'm just making it easier for what we need it for here today, because a lot of the stuff you see here is just not important to what we're dealing with. Okay, that's better. Again, this is kind of irrelevant as well, so I'm gonna knock that out of here. Not to be confusing. You don't need extra junk. Probably should have did this before we got in the call, but Rod had an emergency thing he needed my help with, so I got that done for him real quick. All right. We'll get rid of that note too, because a lot of times this won't be the case for what we do. The stringers are typically going to be actually made out of metal, and so we wouldn't be able to miter anything to that. I guess, yeah, whatever. We'll call it a newel post too, but all right. That's a lot better. Okay. Here we go. That's a lot better. That's a lot easier to see what's going on. So again, for staircases, the big things you're going to see all the time pretty much are going to be verbiage called like things like your handrail, which is pretty self-explanatory. That's just like the handrail that goes along the staircase for people to hold on to as they're climbing or climbing the stairs. You got your newel posts, which are typically going to be like the main guys, the big posts that are at the tops and bottoms and at the landings. Although it's not called out on here, one other thing that you're going to see is landings. So landings are just a larger flat portion of the staircase. You see them all the time on commercial staircases, and we'll be definitely seeing one here today. So then from there, along the sides of your stairs, you're going to see things called stringers. Vertically for your staircase, you're going to see risers for the verticals and treads for the horizontals. Below your tread, there's pretty much always going to be a nosing or an overhang. And oh, I forgot about balusters. I mean, a lot of times we don't deal with that, but I left it on there in case we do see it sometime down the line. But what I'm going to do is I'm going to flatten this. I'll save it over to our group chat for those that are in here today. And maybe I'll just take a screenshot of this. I can get a nice, there we go, a nice zoomed out version of it.
We're not going to have a quiz after this, are we, on these terminologies?
Hey, I could totally make one up if you guys want.
No.
I could definitely do that for stairs. All right. So there's
promise you I'll fail it.
There's some stair terms right there. All right.
Now, we should make it open book.
It's open book. I have the book here. I don't know how that would really help, but all right. So we'll close out of that. It's not really important here. So, all right. We'll go over some staircases that I've seen before. I got pictures of some that we've done in the past. And then we'll get into the one we're working on today. Let's see. Be under my documents, backgrounds. Okay, let's dig in here. So first staircase I have in my list of things here is for a project called Accenture, which these pictures are a little bit small. What's that, the coffee? Yeah. All right. So anyway, this was for a project a long time ago called Accenture Phase 2. Oops, wrong screen. I was trying to pull over the photograph so you can see it. So these pictures are a little small. This one was an interesting staircase because it's not standard or typical in most cases, but you can see a lot of the same things that we just talked about. So this staircase, the actual treads and risers were made out of solid timbers, which I don't remember if they were truly recycled from railroads, but they may have been. I have to ask Caleb about that to see if he remembers. It's been a hot minute since I've looked at this one.
I bet they weighed a ton.
Oh, they sure did. Yeah, we had to have specialty, I think, specialty hardware to make sure they weren't going anywhere because they weighed a lot. Yeah, these are pretty cool. It's kind of like a railroad inspired office space that we did a while ago. But again, just like the one we're going to look at today, you can see that there's a planter and a little bench going on underneath for that same reason too, just to make sure that nobody that has a seeing disability is able to accidentally walk into the metal stringer or anything like that and hit their head or injure themselves. So going up these stairs, these ones don't really have a nosing because they're just straight up beams. But there's a landing right here, which we couldn't really see in that graphic I sent to you guys, but the landing would be like this flat square portion where the stair kind of goes up, turns, and goes up the other way. So there's actually two landings on this staircase. You can kind of see this one has this small landing up here at the top, and then one here about halfway down. Well, a little more than halfway down. Got your balusters, which in this case were metal. It's pretty normal. Handrail, which actually goes and miters down, terminates at the floor. And then sometimes you'll see these two. A lot of times I'll refer to that as like a guardrail instead of a handrail. There's like a secondary handrail up there, which will allow people to like it's well, not really 100% sure the purpose of it. It might just be to keep people from jumping off the edge or falling off the edge of it, but really it's there between the handrail and the outside of the staircase. So you'll see that a lot too. So we got balusters, we got handrails, landings, technically treads. Maybe if you want to consider that a riser, even though it's all part of the same thing. So that's a staircase that we've done recently, well, in the last few years. Let's see. Actually, it was quite a few more years back down the road. The picture going up those stairs. All right, let's see what else we got. So moving down the list of pictures that I have here. Oh, a lot of them are circular stairs because those are like very, a lot of those are very like photogenic staircases, if you want to call them that. Oh, here's one. This one was drawn by a different drafter, but I still kept it here because it's kind of another great example of a staircase. So this is, I can't really zoom in for some reason. This is a kind of a standard staircase too. You got your stringer on the outside, stringer on the outside, treads, risers. This one actually has nosing on it too. You can kind of see the shadow of it overhanging right there. And you can see a little better right here too. This one we actually did do the handrail and the guardrail on it. So we have this top cap here that goes all the way up to the top, and it actually goes all the way around the entire perimeter of this opening between these two floors too. And we also did this handrail here that goes all the way up. So yeah, pretty cool. That was another kind of fun one. Let's see what else we got. We'll get into this too. But there's also something called stadium stairs or stadium seating. Usually built similar to how we would build a staircase. However, it is going to be made specifically for sitting on. So here's a good example of one here. So there actually are stairs on the outsides. The middle is just essentially just a bunch of benches here. So, all right, let's keep on moving. See, is that one? Can't remember. I guess that was considered stadium stairs there too, but I'll skip over that one. Everybody's all excited because the coffee's here.
I would be too. I'm excited for y'all, even though I'm not there today.
I can't drink any more coffee or my heart's gonna explode.
Oh, that's just an urban myth.
I'll be on like 1,000 ways to die here if I drink any more coffee today.
You got to
All
build up a
right.
tolerance. It's just like
Yeah, no,
alcohol.
it's hard. Jeez. Well, this is a big old staircase we did here in Georgia too. This was
That's
for
cool.
Norfolk Southern. This was or before any of our work went in. They took this really cool picture of the steel that was we. That's like what we were talking about earlier, the steel that we have to build our stairs around, or what we're cladding it with. So the steel people put in all their work typically, and then we come in after they're done and we'll put our stuff in. So this picture was taken before any of our work was installed. So the building's kind of bare bones there. You can even see the studs in the walls up there, the framing in the ceiling. The floor's not finished or anything. It's pretty bare bones. But I got several pictures of this one. I might just I'll skip to like some of the other ones that actually show the stairs on it once they're installed, because that happened a lot later. That was a major project. Okay, here we go. So there's something wrong with these. I don't know if this is a panoramic picture or what, but don't mind the squiggliness of the steps. I'm not really sure what happened there. But these stairs had, well, we built all this white portion of it. The veneer panels that are here, this handrail that's here, and the stairs, these treads, and the risers here. That was all part of our scope. Going up the stairs, there's a picture of going down. There's a piece right here that we didn't really talk about yet. A lot of times they'll call that like a transition strip or like a let's see, anti-slip insert. There's a lot of different names for it, but really what it is if you're looking at a staircase like this and you're going down it, if you don't have anything that breaks your visual between the step and the next step, somebody might trip and fall down that thing. So a lot of times they'll put these in as more of a visual to say like, hey, there's a step here, kind of like when you are out in public and you see like a yellow painted curb or something. It's kind of like that as a way to say like there's a step here. A lot of times that'll be made out of like some kind of a grip paper or like sort of like sandpaper a little bit. So it grips your shoe to keep you from falling if you start to slip. Um, okay, let me skip through these. So many pictures of that one. All right, let's see what other ones I got. I think I have some from Google too. Somewhere. Here's some Project Varsity stairs. This one was unique as well in a different way. Um, this one here, this picture is taken, I think, previous to the treads going in. I kind of nicknamed this one the bird cage staircase because it literally looks like a bird cage going up there. Um, but this one was unique in a different way because we had to build treads that, and these aren't actual real treads; they're just decorative. But um, these treads had to be built. You can see the seam right there if you look close enough. They had to be built with the ability to remove this piece and remove this piece here. So that way you could clip them around these posts. It's kind of a weird one, real pain in the butt, but we got through it.
It looks like a weird
Actually,
one anyway.
you could see the
Because
seam there. Yeah. What were you saying though?
um, it just looked weird because from that last picture, it looked like
That one.
Yeah, that one. Yeah, look like the stairs are unusable. They got you blocked in. Like, what's the point of the stairs?
Well, that's at the very top. They wanted it to look like it continued, even though this didn't go anywhere. It was like a staircase to nothing. So they had us build. Oh, that's kind of cool. You can actually, I didn't notice that. You could see the side of the tread without that clipped on piece. Um, anyways, they wanted this to be more of a visual thing, like an art piece, to look like the treads continued to go all the way up to the ceiling, even though there's nothing that you'd be able to get to if you went up them. So they just barred them off like that. Kind of silly. Now that one was weird because we had to get we ended up getting a 3D scan of the building after the metal was installed. So that way we could actually make sure that these holes were lined up exactly where these tubes are going through, which was a real tedious process, but we got through that. That was something I don't know that we're ever going to have to do again, but it was kind of a interesting case. We also had these panels on the ceiling too that followed the perimeter of the stairs too. All right, let's skip to the next. See what else we got. What else? If anything, that's on a staircase we built, so I'm not gonna pull that up. Yeah, well, I think that's about it. I got one more here if you want to look at it, but it's really not that crazy. This is for a project called SGR that we did. Again, you got a landing right here. Below, you got a couple of treads going up. This one didn't have any risers, kind of. The one that we're drawing today isn't going to have risers either. So it'll be kind of weird. Kind of like this one, though. And the stringers were actually set in a little bit. You can see them under the steps right there and right there. And then on the edge, instead of a stringer, what they did was they had glass panes with these little standoff caps that held the glass onto the side of the tread. It's pretty cool. So if you look at it from the front, it almost looks like the treads are almost floating in a way. I mean, you can obviously see the stringer below it, but it's kind of a fun one. And
It's almost
again,
like there's nothing there.
Yeah, it's pretty sleek. And you got this platform below. Again, part of the ADA Act, so that way you got like a cane detection guard, so somebody doesn't run into the side of the stairs. That staircase we just did panels on, so I'm not going to really talk about that one. That's probably about it for what I have for stair photos. We can talk about these stairs that we're dealing with today, though. So, all right. What we got? Aha, we got a Jordan.
Sweet. Welcome to the
You
party.
didn't miss a whole lot.
Oh yeah, dude. Sorry about that. I didn't even see that message. I just saw it now. I was like,
It's all good.
wait, I have a message on Teams? And I looked at it, I
Yeah,
was like, oh, we're gonna go over some stuff later. I'm like,
yeah.
oh crap, you sent this at like 8 o'clock. I'm like, what am I doing?
You're all good. We didn't really go over a ton yet. I kind of scanned in a picture from this AWI book that I have here and doctored
Okay,
it up to show like the different terminology that you see on staircases all the time.
sure.
So that's all in the recording. We got the picture here in the chat. We are just kind of looking at some pictures of stairs that we have done in the past too, but I do have a staircase that's actually going to be due sometime next week that we can look at together today, and I think we're going to try our best to get a good start on it today. So that staircase is this guy. Might be a little crazy looking at first. I kind of briefly went over a little bit of it with Cody earlier. So this staircase has a little planter below it. They usually will have a planter or a bench underneath, and that's as more decorative, but it also serves a purpose for people with like seeing disabilities. It prevents them from accidentally like running into the side of the stairs if they have one of their walking canes or detector canes. So that's why they exist, and a lot of times you will see those on stairs. As you draw them, you'll see them all the time. But the staircase isn't super complicated. It is just a straight run. It does have what's here called like almost like a floating tread. So the steps are, I mean, they have steel in them, but they do like kind of look like they're floating in a way because they're kind of going up here without anything like underneath. Like there's no riser here. We're just seeing the treads there, and that's what they're going to look like. Then there's these landings here. We did negotiate with the steel vendor because originally they only had like 3 little plates underneath of the staircase like this. We negotiated with the stair vendor, and they're going to actually put a full plate like this below, so that way we don't have to worry about our landing having to be structurally like sound and support the weight of people like standing on it, because if there's nothing in the middle here, that could like end up being kind of like a I don't want to call it like a liability, but really it could be a a problematic thing if you have something there and it ends up breaking or falling apart. So we negotiated to have more steel added in there just for that reason. These stairs have these stairs do have stringers below them. They're kind of set in on the sides a little bit. You can kind of see them right there and right there. That's these straight runs that go below. So, and again, they look like this. That's what they are. Usually pretty heavy duty steel tube. So we have that there. Let's see what else we got. There's a close-up of the landing and a close-up of the treads too, so you can kind of see what they're intending for them to look like. And what we're looking at here today too, Jordan, is these are the metal vendor drawings for the staircase. A lot of times what we'll do is we'll actually request these ahead of time because we want to make sure that we are coordinating with the metal vendor, because the metal vendor is a different subcontractor that works with the GC or the general contractor. They're hired by them to build whatever the architect needs, just like we are. But an architect might draw a staircase, but they may not draw it completely accurately. So what we'll do is we'll try to ask the metal vendor if they can send us what they have for their drawings, so that way we can make sure that whatever we build is going to match up with what they're building. So that's why we're looking at these here. They look a little bit crazy because they got weld symbols. They got a lot of other dimensions we're not used to seeing. But we're going to be able to use these to make sure that our staircase is drawn accurately. Let's see. The other thing that they did that was really neat was, I'll pull it up here. They sent it over in an email. They have and I'll send the link to it as well. They sent over yesterday. Where is it? Oh, right here. I'll copy this hyperlink over so you guys can see this and mess with it too. I was playing with this right before I left yesterday because I was like, this is really cool. So the stair vendor, or the metal vendor that's doing the metal for the staircase, they provided a link to a preview model viewer for their staircase, so you can kind of see what this is going to look like. You can actually like zoom in and out on this thing. It's pretty neat. I don't know if I was able to hide any parts or anything like that, but oh, you can. How about that? That's cool. You can literally see how they're going to plan on building these, and it's going to actually help us with designing this too. Anyway, we usually don't get something like this. This is pretty high end, but it was kind of neat to be able to mess with this and be able to see what they're doing. But again, if I flip it around, so I'm looking at the back of the stairs, you can see that they have two stringers. There's one here and one here, and they follow the entire path going up the stairs. We got floating treads. Underneath those floating treads, there's a steel plate that is welded into the framing of the staircase, so that makes it all supported. From our end, we're just kind of putting these wood stairs over top of the metal, so they're already structurally sound. We just have to kind of clad what they have provided. They did leave the planter in this little translucent kind of layer because right now the planter is kind of undefined from the architect. And we've been instructed to kind of hold off on that part of it. So we can work on the stairs, but we kind of have to come back to this later. All right. For us today, we don't have any sort of scope in regards to the handrail, the guardrail, or the balusters, or any of that stuff. All that will be provided by the metal vendor as well. So really our scope of work that we're providing for the staircase is going to be what we're doing to clad the treads, the landings, and I think that's it. Yeah, so that's about it. And then the planter, of course, too, but that's going to come later. One thing to take note of too, I just noticed this as well, is that this planter is kind of built around the bottom of the staircase too. So although it's not clearly drawn in, this has to kind of mimic the stairs going down. So for what we're going to draw, we're going to put a placeholder in there for that. We're not going to go into any great detail for the planter just yet, but we can kind of show like what they did and draw in like a sort of like model of what's going to be there. Kind of like just a basic shape of what it is. And then once we have more information, we can build off of that from there. All right. I think we can get moving on this, but oh, I'm also going to send their metal shop drawings to the chat here too. That way you guys also have that too to look at. The same thing that I'm looking at here. And if you do want to sync this job, the project is 6358 Bradley Law. It is kind of an older project, but they just added the 19th floor into our scope. So oh, okay, sorry, just making sure I didn't miss out anything there. Okay, 19th floor drafting hand offset. Let me send that over real quick here to you guys. Boom. Okay. Here we go. All right. So I was debating whether or not we need to 3D model the staircase, and realistically, we actually won't have to model this thing, but I kind of want to anyway, just so I could work with you guys more in 3D a little bit. So my plan is we're going to start by drawing in a tread, and we're going to make that tread into a block. And the reason we're going to do that is that if you turn your tread into a block, it will allow you to be able to, like if you get red lines back later, let's say you got red lines back later and you're looking at your section view through your tread, and they're like, okay, yeah, this looks really good, but we want to add in like one of those transition strip things like this at the front of your stair tread. And you know, it's kind of a lot of work if you have to add that into every single stair tread, because you're dealing with like probably at least, I don't know if it tells you here. Usually it tells you how many treads there are, but let's just say there's, oh, it says 11 treads there plus another 11. So each floor is 22 treads. So any small change, even as small as something like adding a strip there, you'd have to add in it like you'd have to add that to 22 different treads per floor. In this case, there's 2 floors, so that means that we'd have to add it in 44 times, which is kind of a real pain in the butt. So what we're going to do is we're going to block or turn our stair tread into a block, and that way, if a change happens like that, you will only have to update one stair tread, and it will update all 44 of them automatically. I'll show you how to do that. It's really not that hard, but when it comes to doing things that are repetitive like stairs, I really, really, really suggest we do that because it's going to save your life later. Well, in a way, to save your amount of time that you have to spend spinning your wheels trying to correct or change anything on it. So, all right. So we do have some hold to dimensions we got to pay attention to on these stair treads. So before we even draw anything, let's look at that. Looks like the stair treads are 3 inches tall. And then they want them to be 1 foot wide. So 3 inches tall, 1 foot wide. And then if you look at the front, we kind of talked about nosing a little bit earlier as being the overhang dimension between the stair treads. And the staircase has a 1 inch overhang or a 1 inch nosing here, meaning that like visibly from the top, you would see 11 inches, but really this would actually be 12 inches wide in total. So also something to look at too. I know these are drawn as like solid beams. You usually won't build stairs that way. What we'll usually do is we build them. Let's see if I have. Trying to remember if I have any pictures of stair treads. I guarantee you I do. Let me see if I could find one real quick. Pictures of stair treads that we've built in the past, because I know I usually hang on to those and I'll send them to our different training groups. Ha, hilarious. A really old practice staircase that we did. Oh, nothing there. Okay. Well, that's okay. I'll show you guys something I did earlier though. So for this staircase, I kind of did Greg a favor to try to help us out later when we were getting to drawing this. I did send him a sketch of what I feel like the treads should look like, and I can use that to kind of go over this with you guys to show you sort of the on-site standard construction for a stair tread. Let's see if I have any here. Where did I send that to him? Was it yesterday? No, I think it might have been last week. Here we go. Okay, so I kind of made this drawing for him, which is just a single page, just kind of detailing out what the stairs would look like. Now, most times what you're going to see on a staircase here is that although a lot of times we will, well, almost all the time, you're going to make your stairs out of solid wood. We do solid wood on stairs for the purpose of it's just more durable. You wouldn't want to do veneer or laminate on a staircase because it's just not going to hold up. So staircases, we have to make them out of solid almost 100% of the time. I don't know if there's ever been a time where we haven't, but it's a really good idea to make sure we make it out of solid. So the way that we do that, and the way that we do that is we will make what's called engineered solid. So engineered solid for us, what that means is that the solid material will be 1/4 of an inch thick. So you can see that noted here. And it will be glued to a 1/2 inch thick layer of plywood substrate. So why that's really important is because solid will eventually warp with the changes in humidity in whatever environment it's in, whether it's in a building or wherever, solid will warp over time. And that's just a given. So to try to prevent that from happening or try to minimize that from getting like really bad, what we'll do is we do press that 1/4 inch of solid and glue it to a 1/2 inch of plywood. And that 1/2 inch of plywood is really critical because what it does is it allows the solid to not, it holds the solid taut, so it's not going to warp. If we were to go and do 1/4 inch solid with 1/4 inch plywood, it may hold up, but really what's probably going to happen is as that material sits in that office space or wherever it is, over time, it's going to start to want to warp because it's not balanced enough. The 1/2 inch of plywood with the 1/4 inch of solid provides enough balance to keep that from warping, whereas anything less than that is going to probably end up warping. So it's kind of something that on-site has like boiled down to almost a science there. So we try not to mess with it. We will always try to use a 1/2 inch of plywood with that little bit of solid, the 1/4 inch at the top. And that's just because that's how we do that. And it's due to keeping it from wanting to warp over time. So really important. That's why that's drawn in like this versus what was drawn here, where the entire thing was made out of solid wood. So real important. Now, that doesn't mean you can't make the entire thing out of solid. I showed Cody an example of a staircase we did that was made out of completely solid wood. But those were solid timbers, which would be a different type of wood that is definitely less likely to warp because those things are massive. But anyways, generally what you're going to see is you're going to see something that looks like this when it comes to stairs. Now, an architect's not going to draw it that way. So what we have to do is we have to kind of take the general shape, like general shape is in like that 12-inch wide by 3-inch tall stair tread, and then we have to build off of that shape that they asked for us to provide. So that's what we've done here. Usually in the middle, we don't have so much space in there. This is kind of a weird case because the metal plate is actually intended to be seen underneath the stairs. So in this case, that metal plate's actually way down here. Usually it would be up in here somewhere. So you could kind of hide it better. But in this case, they actually did want to be able to see it from the underside of the stairs. So it makes our job a little bit easier too. If you notice below the staircase too, one thing that I've done here to help us with installing this is that I put a little 1/8 by 1/8 cork that sits here right between the solid and the steel plate by the steel vendor. And that's intended so that way we don't have to make sure that this lines up perfect with that. Like the solid doesn't have to be completely snug to the side of that metal. Because if we did have it completely like we wanted to make it completely flush, again, over time, even though we do have it as engineered solid where it's going to have less likelihood of warping, any slight amount of change is going to be pretty noticeable. So even if it's like, you know, even if it's as minimal as like a 1/16 of an inch or 32nd of an inch, like you'd probably be able to see that this is not in line with that. So we break up the visual line of sight by putting in that 1/8 by 1/8 cork here. That way, if this doesn't move at all for any reason, you're not going to be able to really tell. It also makes it easier for us too, because then the installers don't have to fight with making sure everything's lined up so much because they would have to spend all day out there putting these treads in and it would just take them forever. So it's helping them as well, but also making it more visually, like aesthetically pleasing to look at too, where it's not going to have like things that look like mistakes on it. So that quirk's intentional for that reason. You can see there's a little bit of shim space here. A lot of times on stairs, I've talked to Trevor about this, who is our install guy right now, and one thing that he usually will ask for us to provide is about a 1/2 inch of shim space, and I think this staircase is a little bit less than that. I think it's like 3/8 or something like that, maybe a 1/4 of an inch, which should still be okay. The important thing is you usually do want to have some kind of a shim built in or shim space built in. Not that you can't trust the steel vendor to build their stuff to the exact size that they're supposed to build it or the exact height. You want to make sure that if there is something that's not quite right with their stair or their metal, that it doesn't affect the way our stairs are built, like the stuff we're putting over the top of the steel. So we will put in shim space intentionally because it will allow us to be able to either raise or lower our stair tread to correct any mistakes that are in the steel. So also really important too. So shim space below or within this inside of your tread, if you can get it in there. Usually we try to aim for about a half an inch, but sometimes we'll go as far down as a quarter for that, and that usually makes it okay too. But you don't want to try to build a staircase without shim space because it could result in like things not lining up just right. So again, this one's a little weird because it does have a lot of space inside of it. So we'd put an 1.5 inch block of LSL on the inside. There's the solid blocking. Oh. And LSL, if you guys haven't seen it yet, LSL is a very, very strong like material. It's a pretty dense substrate material that we can use sometimes in place of steel when you need to support a large span of like unsupported countertops and things like that. We don't use it very often, but it is something we can buy and use. And in this case, this is what our listers wanted us to put in here. So we're going to run with that. We have an 1.5 inch block of LSL in the middle, 1/4 inch of shim space below that. Then you have your steel plate by your steel vendor. So really, the main thing for you guys to take away from this is really when you draw a staircase, make sure that you do, if they show it as a solid, completely solid piece of material, just make sure that we are replacing that solid material with that 1/4 inch of solid and 1/2 inch plywood type of engineered lumber. That way things don't warp and get crazy out there in the field. All right, over here, similar to that, this here is a section through the landing. So the landing is made the exact same way as the treads. The only difference in this though is that it's a lot larger. So it's a lot wider here. We got 73 inches total. I put a break line in the middle here so you could see how I was able to separate that and get it to fit on the paper. But if I go down to the full view down here, and if I go back to that model, I can show you something here. So originally, the metal vendor had provided these 3 grade out boxes here to support the tread, or sorry, the landing. And we came back and told them, hey, like, we're not comfortable with just having those 3 points of contact to support the weight of this and to support the weight of people walking on it. So they went back and they agreed that they would put in a flat plate of material that goes from the front to the back of the tread right there. Other than that, the construction of the top part of this does not change. That all stays exactly the same as the treads, but below the tread or below the landing, there are 3 portions here that are hatched with MDF. And those portions are actually going to be veneer panels here. The veneer will be to match the solid. So hopefully it won't be that noticeably different. Although the difference between solid and veneer is somewhat noticeable, but we're going to try to get by with just using veneer below because this plate is a 1/2 inch thick. And going back to what we just talked about for the tread construction, when you're dealing with something that's a 1/2 inch thick, if you try to make that a solid, I mean, you would only have a 1/4 inch of solid with a 1/4 inch of a backer or plywood substrate, which could end up warping over time. So we're going to try to sell them on the idea that these need to be veneer if they want to make them a 1/2 inch thick. So that's why we're using veneer there versus solid. Again, that's really just to prevent it from warping. So that's hopefully going to keep that from happening. I guess one thing I didn't do, which we are going to have to do on our drawing, is I just noticed I did not provide a quirk like this between the steel and the panel. We're going to definitely want to put one of those in. So I'm going to sketch it in here, almost like a correction for my own self to remember to do this later. Come on, there we go. Well, actually, that one can stay like it is because it's butting into our own material. So there's already a quirk there. We don't need to add another one to it. But anywhere there's a change between metal to our scope, I'm going to put one of those in just to make sure that this does not have to line up perfect with the steel. All right. All right. You guys got any questions or anything so far? I'm throwing a lot at you guys right now, so let me know if you do. Okay, cool. All right. Whew. Well, I'm gonna keep on moving then. So, let's see. Well, we can get into drawing our stairs, I guess. So we'll go into AutoCAD. We'll pull up the Bradley Law drafting template and then get to working on that. Oh my gosh. Geez, that took forever. I realize I'm on a phone call, but surprised that that AutoCAD took that long. Bradley Law. Here we go. Oh, oops, I accidentally saved this in the template. That was my bad. All right. Delete that. Okay. So I'm going to leave this alone down here. It can be a template for us to work off of, but we've kind of already gone over the details of how we're going to build that. So if anything else, we can use it as a way to make sure that we're double checking our work to make sure that like we're matching up with what we've already presented to them is what we're going to try to build it like. So let's go and just like we have been doing, actually, hold on. We'll split screen this a little bit. Try to make it so you can see both my AutoCAD and my Bluebeam here so you can see what's going on both screens. Okay. So what? All right. So let's look at our, make this full screen just for a sec. Let's look at our top-down view here. I just want to see some things before we get going. Mostly what I'm focused in on is I'm looking for my standard dimensions for each tread. So we do know that a tread is going to be 12 inches deep and 3 inches thick, but we also need to know how wide it is from edge to edge. And a lot of times these metal drawings and the architectural should show it. Now, the architect really didn't draw these stairs, so we're just pretty much going blindly based on the metal shop drawing here. So we have a dimension here. It looks like 5'5" from outside of finished tread to outside of finished tread. So that'd be 65 inches wide for each tread. That should actually apply to both sets of stairs because we are dealing with two different floors here. We have I think this goes from 19 to 20 and then from 20 to 21. So fortunately, they're both going to be almost like copy paste of each other. So really we're drawing one staircase that really pertains to, we're kind of building two with one. So killing two birds with one stone, one stair. All right. So 65 inches wide, 12 inches deep, 3 inches thick. I got to remember those three numbers. So let's go and go back to AutoCAD. Okay. And because I've already got this drawn in, what I'm going to do is I'm going to copy my, I'll copy this tread and the steel plate too, because why not? We're going to copy that over to the side, over where our 3D model lives. We're going to paste that there. Now, before we go any further, we do want to make sure that, one, we get rid of all the hatching that's in here, and then two, that all of these polylines that are in here, well, we got to make sure they are polylines first, and then we got to make sure that they are closed as well. So just like we have been doing, we're going to highlight all of that. We're going to go into our properties menu. If you don't have that pulled up, you can just type in properties, or I think, Cody, you've been doing it a different way too, which I thought was kind of cool. If you right click and then go to properties, it'll pull it up as well. Now, one thing you can do is when you're in properties, you can go over to this quick select option here, which will allow you to change what you have selected currently to eliminate things you do not want to delete or vice versa. So we're going to open up quick select. We're going to go in here. We're going to tell it that we only want to select hatches. So we're going to say object type hatch. And then instead of selecting one of these, we're going to say operator from equals to select all. So if we do that, doesn't matter what type of hatch, what layer it's on, it will select anything that is considered a hatch. And then just make sure that include in new selection set is checked here, and then you can hit OK. Okay, so once you have that, just delete the hatching there. These, you can technically get rid of that too. That's that line that just says, hey, this is the shim, a shim between the metal and the LSL that's inside of the tread. And then the last thing we're going to do is we're going to go through here. I noticed that, oh, maybe we got rid of it. Okay, so we are only selecting polylines at this point, and it looks like if we look down to miscellaneous here, it says that all polylines are closed. If there was one in there that wasn't, what it would say is it would probably say varies for this. And then you'd have to locate which one isn't closed. And then either do a B poly on that polyline or join to make sure that it's all actually closed. So anyways, from there, once you have confirmed that everything is a polyline and that every polyline is closed, you are good to then actually start making this in 3D. All right. Here we go. So a couple ways you can do it. We've talked about these before. You can use your press pull command and highlight each part that you want to actually create a 3D object off of. You can use your extrude command to also do the same thing. Extrude will allow you to highlight everything and then make 3D objects off of that. I think the difference is extrude will delete your polylines after you've extruded. So you want to make sure that if you do need this for any reason, you make a copy of it. Let's see, what else can we do? Well, we'll use the extrude method because that is going to be definitely the quickest way to do this here. So let's click on extrude, highlight all of our lines, and hit enter. And then we're going to tell it this needs to be 65 inches to match this tread here. All right, so 3D rotate. Okay, so we should have one tread. Ta-da! Okay. So that's pretty much the construction of the tread, but we can't just leave the edge of it like this unless it's capped off. If it's not capped off, then or sorry, if there's nothing blocking the view of the side of it, then we have to figure out a way to make this officially like closed off in a finished end. So I'm going to go back to that model link I sent you guys a minute ago and pull that up because I do want to check to see what they have drawn here, since we don't really have a lot of architectural references to look at. Okay, just going back to this. Okay, so yeah, it looks like we're going to have to cap these off. Woo! Looking at the side of it. Come on. Zoom out. Okay, there we go. Looking at the side of it, you can see that there is veneer, or sorry, not veneer, solid on the outside edge of it. So we're going to be finding a way to cap this off in our model then too. So let's go back here. Okay, so for us to do that, we need to use the same method of approach. We do need a 1/2 inch of solid with a 1/4 inch, or a 1/2 inch of plywood with a 1/4 inch of solid on the top of it. So that totals out to be 3/4 thick. So what we can do is we can, let's see. Well, first off, we can press pull these objects in. Let's see. Not necessarily that, but the LSL and the shim do need to come in 3/4 of an inch. So 0.75 this way. We got to do that on that side and the side here. So again, press pull, hold down my shift key so I can select multiple objects. And I'm going to shrink this in 0.75. Okay. Then I need to figure out, because that's my steel plate right there. I'll make that the gray color so you can see the difference there. So that's my steel plate. I need to find out on the steel vendor's shop drawings how wide that steel actually is. And I'm hoping that they have it noted somewhere. It should be on here somewhere. Just got to locate that. Nothing there. I wonder if you can scale things off of that model they provided. If it's not shown here, I'm going to try that and see what happens. Yeah, it might do that. I'm going to give it a shot. Let's go back to that and see what we can do. Oops, wrong thing. Let's go, here we go. So let's see what options we got for measurements, because maybe there's a way to do it here. And what I could probably also do is isolate. Come on. Let's see. See if I can isolate one steel plate. Well, you can do first person too. Hold on. I gotta see this. Whoa. Okay. Never mind. Let's not do that. I'm gonna reopen that link. I broke something in there earlier, trying to maneuver around their model. Okay. Let's see if we can get to one of these plates. Isolate. That's what I'm talking about. All right. Now, Let's try to measure this thing and see what we can do. From there. 2. There. What does it give me? 63 inches. Cool. Awesome. I guess while we're doing this too, let's measure the depth of it too. So we got the width at 63. And whoa. The zoom is backwards from what I'm used to. So 63 by 10. I'm going to write that one down on a sticky note because it's going to be really important that we get back to that. There we go. 63 by 10. All right, let's go back to our model. There we go. So let's isolate our steel plate. So it should be at 10 inches already because that's what we based it off of from their model. But we need to make sure that this is 63. And right now it's probably at 65. So we need to bring it in an inch from either side to get that to work. So let's press pull the steel in 1 inch and come over here and press pull the side in 1 inch. Unhide. All right, cool. Cool beans. Okay, and let me just check one little thing here real quick. All right, awesome, awesome. Okay, this is gonna work out really, really nice. Okay. Yeah, we should be okay. All right, I'm actually gonna move these in. Sorry, I should have moved it in an inch instead of 3/4. And that way, these can be in line with that steel plate. That is the LSL, the shim space. And there we go. All right. And before we call this tread done, I'm going to take the front nosing, just those 4 parts that are there. We're going to take those, copy them off to the side. And then rotate them. Using 3D rotate, we're going to spin them around like that. I'm going to use my move command so I can place this exactly where we want it to be. Using that top corner of the miter, dropping it there. Then I'm going to slice off anything that is not needed. So highlight my excess parts, grab my endpoint, and then just drag my line with my ortho snap on. I can click over here and then click on the side that I want to keep. So it'd be this side here. Okay. Now, we still have to clean up these corners because that's going to be important. So let's do that next. Kind of like what you guys were doing earlier with your faceted panel training and probably the bar as well. We're going to use the slice command. We're going to highlight all these parts that we want to miter. Okay, I think that does it. And then we're going to go ahead and click this point here. And I need the inside corner, which I can't grab by itself, but what I can do is hover over this point, and then I can hover over this point. And what it'll do is it'll give me a apparent intersection snap to be able to make sure that I have a perfect 45-degree miter. I'm going to tell it I want to keep both sides this time. And then I'm going to use my blue selection box here, highlighting just that corner, then hitting my delete key to remove anything that I don't need. I'll do this one a little different so I could go back over one little thing with you guys. So if you have to miter something and you don't want to do that apparent intersection method, The other thing you can do is, being that we are dealing with something that's like kind of square and lined up where it needs to be, we can go down here to this polar tracking option, and we can tell it that we want to snap to 45-degree angles, which if we do that and we turn that on, now if we go to slice, highlight those same parts that we just highlighted on the other part, other corner. Okay, and then click on my corner. Now what I can do is, if I move my cursor around, you can actually see that it snaps to these 45-degree angles. So just like that, that would be fine. I can click there, tell it both sides again, highlight that corner with this blue selection box, which you can get to by going from like clicking and going from left to right. If you go right to left, it'll highlight every part that touches it. But if you go left to right, it's going to only highlight the parts that are inside of that box. So I'm using that as a way to get to only these parts that I need to get rid of here. So we'll delete that. And then we need to get this here to match up with this here. So I'm going to isolate just those parts so that I'm not dealing with all the extra junk. And I'm going to use the slice command here to highlight those two parts. And this time I do need to use a 3-point slice because I'm not cutting it from the top down. I'm cutting it from the right-hand side and through. And so to do that, I need to go down to 3 points. And then I need to select my 3 points for my cutting plane. So we'll go this corner. That's my miter right there. And then this is going to be the direction I'm cutting through it. So going straight through towards the back. Let's say keep both sides. And then delete anything that's not needed there. What? Oh, your lipstick worked. Jeez. All right. Unhide. Should bring everything back. Okay. Now we have to do that same thing on this side too. So 2 things you can do. I'm probably going to end up doing it anyway, but you could technically mirror that over to here. Actually, we can just do that. Just mirror those parts from this corner using the center of my tread. There to there. Just like that. Oh, oops. I guess I was a little bit off, but that's okay. Come on. Oh, wait. I gotta select all of these real quick here. There we go. All right. Now, we got to clean up these corners again, just like we did earlier. Now, the good thing is we only have to clean up the corners that deal with the front and the back this time, because we've already cleaned up the outside edge of this thing. So we're just going to slice these real quick. So slice from there to there, keep both sides, back out, highlight those, delete those parts. Go again, slice. Only needing to do a 2-point here, so that's going to save us some time. And we're going to go from here to there, keep both sides, whoops, and then remove those parts. And then just like before, I need to highlight those parts from the top of the tread to the side, and we're going to miter those together too. And these are the ones that we have to do that 3-point. Again, because we're not cutting it from the top down view, we're cutting it from the left-hand side this time and going straight back. So I need to slice, boop, boop, those 2 parts, 3 for 3 points, and then that point, and 1 straight back, just like that. Whew. Okay, and we can delete that little guy right there. That's out of here. Unhide. All right, cool. check it out. We have our first tread done. Woo! All right, celebrate good times. Come on. But we do need to make sure that these layers are correct too, because right now my tread is all built on the rib layer, which isn't really correct. So I need to make sure that I'm putting everything on the actual layers they belong to. So again, going back to layer properties, I'm going to switch over to 3D. And I'm going to say, for the top of my tread, the front, the back, all that has to be on the solid layer. So we're going to take all of those and put those on the correct layer, including that guy too. It's that little lip at the bottom. That will also be solid as well. Okay. And then we have a layer behind that. That would be our 1/2-inch plywood substrate that we talked about earlier. We need to highlight all those parts and get those on the correct layer as well. All right. And if your computer fan is not spinning up right now, you're doing it wrong. Just kidding. My computer fan has definitely been spinning all day though. I think it's getting towards the end of its lifespan. I'm gonna make a layer here.
Did a lot of that this past week, haven't we?
Yeah, I'm sure you guys have. I'm gonna make a layer here for shim and a layer here for LSL too. That way I don't have to use the plywood layer for the LSL or the shim. It could have its own designated layer. If you want to make layers for yourself, you can. I'm not going to tell you not to. So what I'm going to do is I'm going to make a new layer by clicking on this little stack of papers with the little sun next to it. And we're going to label this layer as shim. And I'm going to make this be like a pinkish color, I guess. I usually make my shim and my hang cleats pink. That way they stand out. Okay, so that layer's turned off, so those parts disappeared. Okay, cool. But now I got to make another layer for my LSL. Probably take this base plate, label it LSL. Okay, apparently not. LSL. All right, sometimes it does give me problems when I make a new layer, but I went around it. So, all right, cool. Bring everything back, go into my 2D wireframe now. Should be able to see all the pretty colors of what we've got going on here. Yeah, so you can see that I have my my solid wood. I got my plywood behind that. Got my metal in there in the gray layer, my shims in pink. And that just about does it. So at this point, once you have a tread completely done and you are confident that there's nothing wrong with it, you want to double check your dimensions, make sure that everything still adds up to what it needs to be. So 12 inches that way. We should be at 65 inches this way. And we need to be at 3 inches tall. So as long as all 3 of those dimensions are good and you've modeled everything else the way you needed to, we can go into the block editor next. So this block is not going to have any function to it other than just grouping everything together. Now the difference between using the group, because there is a group command, the difference between using a group command and a block command is that if you group this together, it appears to have the same function as a block. But if I change anything on this object, it's not going to change anything on this object. So really, when you have something like this where you have 44 treads, you want to use a block because you want to make sure that if I need to change something, I'm able to do so on every single one without having to ungroup, go through, and manipulate every single tread there. So I have complained quite a bit I'm guilty as charged. I have complained quite a bit about how AutoCAD does not allow you to use three-dimensional blocks. And there is some truth to that. However, you can put 3D objects in a block. You just can't use the stretch or anything in the block editor to edit that 3D object. So I can put this tread in a block as a 3D object, and it's not going to break AutoCAD or anything, but it's just limited. So I'm not able to do anything else with it other than just make it a chunk of a block that just sits there. So I can still edit it in 3D and replace the block and then update all my treads. That still works just fine, but I can't stretch it. I can't do any of the fancy block tools that you have available to you. But we're going to use this here. So we're going to go type in block. Just like when you make a new layer, you see there's that little sun icon next to it. We're going to click on that. And we're going to be presented with this little menu. This is the block definition menu. First thing you want to do is you want to name your block. So you're going to say something like something that makes sense to you. So I'm going to say tread, or yeah, I'll just call it tread. That's what it is. And then down here it says pick point. So what that is that is the base point for your tread. So you don't really need to pick one. I do like to put one on there anyway, just because I like having one set up for me. So I'm going to pick this corner at the bottom as my base point. And then you have this little green icon for select objects. If you click on that, highlight your tread, hit enter, it'll bring you back to this little menu. And now you can actually see the little picture of your block. And there's nothing else in here that you need to change for this to work. So you do want it to be explodable in case you ever need to do that. So you want to say allow exploding. But that's already on by default, so you shouldn't have to change that. All right, so we're going to hit OK. And now if I click on this, and let's say I needed to hide something. Let's say I wanted to hide the top of my tread. I can't actually do that anymore, which is kind of goofy, but you can do some other stuff though. You can still turn off layers and it still works the same that way. But this is kind of like a group now at this point. So now that it's there, it's a block named tread. We don't want to manipulate it anymore unless we have to. If we have to edit it for any reason, you can double click on it and hit OK, and it'll open up your block editor. Yours will look like a gray background by default. I had recently changed mine to black because I realized the existing layer, that gray layer that's there, that kind of is like almost the exact same color as the default background. And I was getting to the point where I couldn't see things that were in the block that were on that layer. So I changed my background in my block editor to black, but by default, you're going to see gray on yours. If you ever want to change it, let me know. I'll show you how to do that. But otherwise, this is kind of the block editor. So when you double click on your tread and open up that block, you're going to see a toolbar pop up called the block authoring palette. But you won't be able to do anything with that today because we're dealing with a 3D object in the block editor, so it's not going to allow you to really use any of these tools. But these are different things you can set up in a block to be able to do some of the fancy stuff that we have for like our cabinet block or other things that you have in your tool palette. You also have a special menu that pops up at the top too that has more block tools up there as well. So usually don't really mess with this too much, but there is some things up there that we have to mess with later. When we get into blocks, we'll talk more about that. Anyway, if you have to edit your tread, you can do it in the block editor. And when you're done, you hit this green checkbox up top. If you've changed anything, you want to hit Save Changes to Tread, and it will update every block named tread in your CAD file. So again, I can show you kind of like an example of that real quick. So let's say I have maybe 4 of these guys. All right. These are my treads. Maybe I'm making a rope bridge, who knows? So if I need to do something like if I needed to drill a hole through the top of this tread, I could definitely do that. Or if I needed to add something to it, like, I don't know. Let's say I needed to add a cylinder to it for some reason. I don't know why you would ever need to, but let's say you needed to. Go 1-inch diameter and throw that cylinder on here. All right, if I hit close block editor and save changes to the block, it's going to make a cylinder on every tread. So that's what I was talking about earlier when I was saying if you block your tread and you have to make a change to it, it makes it a lot easier to be able to do that. So I'm going to get rid of that though, because really we don't need that. That was just for fun. So we're going to undo that. I'll get rid of these because we don't need multiples of those right now. Okay. So from our side, Cody, how you doing on time over there? Sorry, I want to make sure you're good.
I'm all right. I thought it was going to be about 1, but it's looking like maybe more like 1:30. So
Okay. Okay. I'll probably take my lunch when you're having to go, and then I can come back into this too if you guys are ready or want to get back into this later. But what we can do is we can work on setting up the treads and where they need to be. We still have to draw in the steel, even though we're not providing it, but we still want to show how that steel interacts with our staircase. So that's why it's important to make sure we draw it in, even though it's not our scope, it's not really our problem, but we still want to make sure that it like interacts well with what we're building. So let's start with, let's see, got a section view of the treads here. All right. Let's assume that we're working on the staircase going from level 20 to 21, which would be this guy here. I'm trying to avoid level 19 to 20 because there's that planter that's sitting below it right now. And I want to come back to that with you guys when we have a little more time to get through it. So for right now, I'm going to say, let's look at this and pretend that this is the only staircase we're working on right now. So if this here is the first tread or tread number 1, we do need to, let's see, we need to find out, well, here's your dimension here actually. You need to find out how high the next tread is from the face of the tread below. So it looks like every tread is going to be 6 and 9/16 high from the next one. That should be consistent across all of these. So that is a safety, I think an OSHA standard actually, that your treads all have to be the exact same height from one to the next and the same depth from one to the next as well. If they vary, it will likely cause somebody to trip and fall. So that's why there's safety standards with that. So we want to make sure that we're maintaining those. And as long as the steel vendor has that correct on their drawing, then we should be okay with this. So assuming that the next tread is 6 and 9/16 up, what we can do is we can draw a line. I'm going to go here. I'm going to draw a line straight up from the corner of my tread, 6 and 9/16, just like that. Okay. So that will designate the height. All right. But we also have to account that we have a 1-inch overhang. And that is notable on this page here. You can actually see that, and they have it dimensioned. So not only do we have to make sure we get the height right, we have to make sure that the overlap is also correct from one tread to the next. So I'm going to use the copy command. I'm going to paste this. Whoops, hold on a minute. I should have actually grabbed that top point because it needs to be there. Meaning that if I did a distance or DI check on it from the top of this tread to the top of this tread, and the Z direction should be 6 and 9/16. Forgive me, I don't have that one memorized. 5, 6, 2, 5. Okay, cool. So that is correct. All right. Now that we have the height correct, we got to get that overlap correct. So looking at it from the side view here, right now, these are perfectly in line with each other. Oops. Well, let me draw a line there. They are perfectly in line with each other if you look at it from the side. So like that, we need to move this tread block 1 inch over to fix that. So now if I was to check this one more time, I go from here to here. Not only should my Z direction be set at 6 and 9/16, but my X direction is also going to show 1 inch, meaning I have a 1 inch overhang from one tread to the next. So now that we have that, we need to know quantity of how many treads we need to provide for the staircase. So for this particular part here, they have them labeled, which is really nice. And when we get to actually plotting the staircase, I'm going to show you that I actually do this as well. It's a really good way to double check your work because I will tell you I have been in similar cases before where I have not labeled my stairs, and what happens is you may end up in a point where, and this is going to sound really dumb, but you might end up at a point where maybe you draw your staircase in, but you forget a tread or you add an extra tread by mistake. And then, in a staircase like this, it's really not a big deal. When you're dealing with something like a big spiral staircase, it becomes a greater issue because then that affects the entire spiral or helix of the staircase. So you got to be really careful about that when you do a circular staircase. But in a case like this, it's really not a huge deal if we end up doing that. But you want to make sure that you try to do your best not to make a mistake like that. So important notes though, here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 treads, and then the 12th tread, technically where the landing is. So we need to copy these so that we have 11 of these treads right now. So I'll do that real quick. And I'm going to use the COPY copy command in AutoCAD because it will allow me to select a base point. And what I like to do with that is I'll highlight the tread that's on top, select a base point, meaning I can select like this point here. And then what I can do with that is I can use that to then kind of chain reaction, copy these throughout like this, make it easier on myself. Got to make sure I'm grabbing the end point. So right now I have 1, 2, 3, 4, 5 treads. I need to get up to 11. So we're going to go 6, 7, 8, 9, 10, 11 treads. So there's our first 11 treads for our model. So we're already, halfway up the first set of stairs. No big deal. All right. We do have to get that landing model in though too. So that'll be the next big thing we're going to work on together. All right. So, let me just think real quick. Do I want to model that using, I probably need to go back to where my section view was drawn at the bottom. And I probably need to go back to taking that and what we did with the stair tread. I need to extrude it, do my miters, and then really I don't need to turn it into a block, but I might do it just for fun. And in case something like maybe the landing is the same from the staircase to the one below, then I could use that block to make sure that they stay the same. So let's do that. We'll go back down to our section view over here. I go down to my top-down view on my view queue. And something else to take note of too, when you're working between 2D and 3D, generally if you're working on something that's with 2D lines like this, you want to make sure that you're not in a 3D visual style. So you're going to go up to the top left and you're going to switch it back to 2D wireframe. Why that's important is because you will notice that if you switch it back to conceptual, actually maybe it's not that noticeable, but it does create some weird glitchiness and it will actually slow down your computer a little bit when you're dealing with 2D objects and you're looking at them through a 3D visual state. And the same thing kind of, well, doesn't really happen the other way with using a 2D visual state to look at a 3D model, but when you're looking at 2D objects and you're in a 3D visual state like conceptual or realistic or any of those ones, you're going to see some weird stuff happening like what we saw there. The in conceptual, you can see like these weird lines and how my dimension turned into this weird hexagon shape. It's just kind of quirky in a way. So anyway, just important note to take note of is just if you're working in 2D, make sure that you are on 2D wireframe. Otherwise, it could get a little bit slow, could get a little choppy, could even cause you some AutoCAD fatal errors, which we all love. So we're going to avoid that by keeping this on 2D wireframe when we're working in 2D. All right. Before we move on, let's copy our landing over to the side and bring it up to where we're working in 3D over here. Okay. I can get rid of those. And just like before, we're going to delete all the hatching. So I'm going to highlight everything that's here, go into properties. And then in the top right corner by properties, I have that quick select option, which will allow me to highlight object type hatching. And I'm going to say select all hatching. Hit OK. And then I can just hit my delete key and all that hatching is gone. It's out of here. Now, we need to highlight that one more time. Confirm that we are looking at only polylines. Really important. And also really important, making sure that you are looking at only closed polylines. Because again, if you have anything that isn't closed, it's going to say varies here. But the second you try to make it into a 3D object, you're going to notice there's some issues going on. AutoCAD will definitely be making you a mesh model or a surface model versus a solid model. And surface and mesh models are usually used for more of like, I guess you want to call it like more like sculpting sort of in AutoCAD. Like they're kind of more of an artsy type thing. Whereas like a solid model is going to give you more ability to edit and change that model. And it's not going to give you any weird curved corners or anything like that. It's going to be exactly what it needs to be. So the important thing to remember is when you're making something off of a 2D face into a 3D object, you want to make sure that you're dealing with a polyline and a closed polyline. Anything other than that, you will definitely run into some problems. So just heads up there, make sure that you do check that before you go work in 3D here. Anyways, like we did previously, we are going to take that landing and we're going to use the extrude command to be able to turn this into a 3D object. We're going to highlight the entire thing. And we're going to go and tell it, what did we say that was 65 inches, I believe? Yeah, 65 inches tall or wide. So type in 65 here. And then now we can go back into 3D mode. In 3D rotate this guy. So that way we're facing the correct direction. We're looking at the top of that landing. All right. And I will also save these as well. So I'm going to go ahead and save as because we are getting deeper into this model. And I want to make sure that if I do have a crash happen to me, that my work is backed up somewhere. If I don't save it right now and it crashes because I'm working in a template, AutoCAD's going to say, sorry, I don't remember what you just did. It's gone. It's like it has amnesia or something. So what we're going to do is we're going to save it right now, make sure that we're not working in the template. I should have done that from the start. Sorry, guys. But what I'm going to do here is go to Bradley Law, save this in the folder in prelim project. And oh boy, let's save this real quick. So this is S1 PKT. Got to go back to my time card. Okay, so 45719.
Is this a good stopping point after you save it?
We can. Do you need to get rolling?
Yeah, she
Okay.
that she's about done. So
Okay. I'll save this then. I'll probably take my lunch. And then are you guys going to want to get back on later for more of this, or what do you guys want to do?
I
it
can.
doesn't
if,
matter to me.
Okay.
Yeah.
Jeez. Party pooper. Just kidding. Yeah, I'm probably gonna take my lunch, but if you guys are both back on later, we can continue working through this because we could probably finish the 20 to 21st floor staircase today. We could probably even do 19 through 20 if there's time. But the steel part, I'm probably gonna have to do that next week with you guys because that's gonna take a little bit longer. But we could at least get all the treads and landings and our scope all situated. So. All right, I'm saving this again, just make sure it's actually saved. And then I'll close out of this. And if you guys want to continue later, I will just shoot you guys a message, ask if you want to continue. If you do, we will do that then. Otherwise, we can pick it up Monday too, whatever works better. So,
Sweet.
all right. All right.
If y'all do decide to continue, just go ahead and get started, and I'll jump in whenever I can.
Okay, sounds good. And again, I will be really careful to make sure I record it this time. So if you do have to jump in later, and same thing with you, Callie, too, you'll have a recording of it. Again, apologies. Last time I should have been a little smarter about that. I just didn't hit the button. So that was my bad. All right. I'm going to stop sharing and we'll close out of this. And I'll probably see you guys in a little bit. So just let me know. All right. Bye.
See ya.
Bye, guys.